So a careful read of this problem tells us we are looking for the minimum possible exterior surface area, and this is an open-topped glass aquarium. It will hold 32 cubic feet of water, so that's a volume. And let's see, what are they? A square base. Open-top glass aquarium with a square base is designed to hold 32. Okay, so we don't know what the height is, and we don't know what the base is, but we know the base is square. So we're going to make that x by x. They tell us 32 cubic feet. Well, that's a volume. So 32 is equal to x squared times height. And the surface area, I'll call it SA, is what we are trying to maximize. That's where we'll take our derivative. So we're going to have the base will be x squared, and then we're going to have 4 x times h's, because we'll have 4 of these equal sides. So the last thing, notice we have an h and an x. It would be nice to have those all in terms of x or h. So let's divide this second equation by x squared. H equals 32 over x squared. That will go in to this upper equation for h, and we'll have surface area equals x squared plus 4x times 32 over x squared. A little bit of simplifying. X cancels with one of these x's. We're looking at x squared plus 4 times 32. 4 times 32 is 128. I have x squared, or x in the denominator. I'm going to bring it up as x to the negative 1, because I know that my next step is to take the derivative. So surface area prime will be 2x times, or I'm sorry, minus, because then this negative 1 is going to come down, 128 x to the negative 2, or setting this surface area equals to 0, 0 equals 20, or 2x minus 128 over x squared. I will add this term to both sides and get 128 over x squared equals 2x over 1. Now I'll cross multiply. 128 equals 2x cubed. Divide by 2. 64 equals x cubed. The cube root of both sides, well, 4 times 4 is 16, times another 4 is 64. So x must equal 4. When this is 4, that will produce the minimum possible surface area, we think. What do they want? What is the minimum possible surface area? So now we're going to have to use both of these equations. H equals 32 over x squared. Well, x squared was 16. 32 divided by 16 is 2. So that's 2. And our surface area, that's the minimum, will be 4 squared is 16, plus 4 times 4 times 2. Here's 32. I'm terrible at arithmetic, but let's see if I can get this one right. 48. Now we need to make sure that this 4 is actually a minimum. And so I don't know exactly what this derivative looks like. So this time I'm going to have to test. I'm going to test 3. And just keep in mind this was a negative before I moved it to the other side. So when I test 3, I get 6. minus 128 over 36. Not 36 over 9. So 6 minus 128 over 3 squared, or 9. That's about negative 8.22. Now let's test 5. When I test 5, we're looking at 4.88. So sure enough, our derivative is going from negative to positive, making 4 the minimum surface area. Final answer, 4 was the value of x. The minimum surface area was 48.